In today's class, we'll be discussing about irrational numbers. So the type of question that we get here is to locate them on the number line, for which we'll be using something called Pythagoras' theorem. Pythagoras' theorem. In this theorem, we consider a right-angled triangle. Right-angled triangle is a triangle in which one angle is 90 degree. This angle is called the base angle, denoted by theta. The side opposite to 90 degree, this side is called the hypotenuse. As you can see, this is the longest side. The side between 90 degree and theta is called the base, and the side opposite to theta is called the perpendicular. Denoted by B, denoted by H, and denoted by B. So according to Pythagoras theorem, hypotenuse square is equals to base square plus perpendicular square. This is our theorem. So the question: locate root 2 on the number line. For this, first we will construct the number line. We'll take gaps of 1 centimeter each. After this, we'll be using Pythagoras theorem. So, by Pythagoras' theorem, hypotenuse square is equals to perpendicular square plus base square. Now, in the next step, we are going to choose perpendicular as 1 unit and base as also 1 unit. So we'll get h square is equals to 1 square plus 1 square. 1 square is 1, 1 square is 1, 1 plus 1 we get 2. So h square is equals to 2. When we change side of square, what we get is a square root. So h square is equals to 2 implies h will be equals to root 2. Whenever we change the side of square, we get a square root. So h is equals to root 2. So from here we conclude that if we take the base as 1 unit and we draw perpendicular of 1 unit, the hypotenuse that we will get is of 1 unit. So we'll draw the base as a 1 unit. We are taking this base from 0 to 1. We'll draw a perpendicular of 1 unit. Make sure that this line is perpendicular to the number line. So we took this as 1. We drew the perpendicular as 1. So the hypotenuse that we get here, this is our hypotenuse. So the hypotenuse opposite to 90 degree that we get here is equals to root 2. So now let's see this point B B, this point B, A. So what we'll do is we'll take a compass and we'll take OB and we will pull them to the x-axis. We are keeping this mark, this pointed end of the compass at O. We are taking the measurement till B, and from this what we are doing is we are drawing it to the number line. So the point where it cuts the number line, this point is root 2. Let's mark this as C. So this implies OB is equals to root 2. Next, what we are doing is using a compass, with center O and a radius OB, draw an arc intersecting the number line at point C. Then C corresponds to root 2 on the number line. So this is how we are going to solve question for root 2. Second example, let's take for root 3. So locate root 3 on the number line. Solution. In the beginning, like before, we are going to make a number line. Going to take gaps of 1 centimeter each. Now to locate root 3 on the number line, again we are going to use Pythagoras theorem. Pythagoras theorem, hypotenuse square is equals to perpendicular square plus base square. Now in order to get, see, for hypotenuse to be root 2, the square of the hypotenuse should be equals to 2. So for the hypotenuse to be root 3, the square of the hypotenuse should be 3. So we need to divide this number 3 into two parts such that one part is with perpendicular and the other part is with base. So there is only one option, is to take 2 and 1. So say if the perpendicular is 1, so the base must be equals to root 2, because the square of root 2 will give us 2. So when we add 1 and 2, we'll get 3. So we get 3. So hypotenuse square is 3, which implies hypotenuse is root 3 unit. So what we are doing is we are choosing perpendicular as 1 unit and base as root 2 unit. Again, to draw root 2 directly on this is not possible because root 2 is again an irrational number. So we'll use the previous way in order to draw the value of root 2 on the number line. First of all, what we'll do is we'll take 1 centimeter here. We'll just bold it. Then we'll take 1 centimeter perpendicular. First we are finding the value of root 2. So this value that we get is of root 2. This value is root 2. Now with root 2 as base, we need a perpendicular of 1 unit. So from here, this is our base now. So from this base, we are taking a perpendicular line. We are taking a perpendicular line and we are drawing root 2. Sorry, 1. So root 2 is our base. Base is root 2 and the perpendicular is of 1 unit. This is of 1 unit. This is of 1 unit. So the hypotenuse that we are getting here, this value is root 3. So with base as root 2 and perpendicular as 1, the hypotenuse that we get is of root 3 unit. So again, we'll take a compass. We'll take the length of root 3 and we will make an arc so that it cuts the number line. Let's say we mark this as A, B, C and say this point is P. So this point over here, C, denotes root 2 and this point over here, P, denotes root 3. So this implies OC is equals to root 3 using a compass with center O and radius OC. Draw an arc intersecting the number line at point at point P. Now we are intersecting this OC at point P on the number line. Then P corresponds to root 3 on the number line. Next example, say locate root 10 on the number line. This question is a bit unconventional. Why I am doing this question is because you can have a variety of examples to refer to in order to solve your questions. Just like before, we'll draw the number line. We'll take a gaps of 1 centimeter. again by Pythagoras theorem. Hypotenuse square is equals to perpendicular square plus base square. So we need a total of 10. Since hypotenuse square we need 10 here, so that the hypotenuse can be root 10. So hypotenuse square should be 10. Hypotenuse square is 10 means we need to divide 10 into two parts of P and B such that their sum becomes 10. So there are a number of plenty of ways you can do this. You can take say P square as 6 and B square as 4. So B becomes 2 if B square is 4, and P square 6 means B becomes root 6. To find root 6 would become a difficult task, so we need to choose the numbers in such a way that we get easy numbers to solve with. So what we'll do is we'll take 9 and 1, because 9 plus 1 will become 10. Hypotenuse square 10 means hypotenuse will become root 10. So if we take 9 and 1, so 1 square is 1 and 3 square is 9. So what we'll choose is, we are choosing P as 1 unit and base as 3 units. The choice of this units, how much units we are taking as perpendicular and base, is completely by hit and trial method. You try, you put one value, you try it. If it doesn't satisfy, you try another one. So on putting 1 and 3, so it becomes 1 square plus 3 square. 1 square is 1, 3 square is 9, 1 plus 9 is 10. So h square is 10. This implies h is equals to root 10. So the hypotenuse we are getting is of root 10. So what we are doing in this question is we are taking the base as 3 units. And we are drawing a perpendicular of 1 unit. So the hypotenuse that we are getting here is root 10. This is 90, this is 1. So the hypotenuse we are getting is of root 10. We'll take a compass. We'll fix the center at O. We'll take this length as our arc and we'll draw an arc. So we will name this point as A, this point as B, and this point as say P, and this value is of root 10. So this implies OP is root 10 or OB is root 10. In the similar way, we will write it in this just like this using a compass. With center O. And radius OB. Draw an arc intersecting the number line at P then P corresponds to root 2 on the, so to root 10 on the number line. The second topic we are going to deal with in this chapter is real numbers and their decimal expansion. The theory for this we have already discussed before. So real numbers in their decimal numbers is terminating when the rational number p by q, the denominator, has 2 and 5 as its factors. Means we are taking q as multiples of 2 and 5 only, where m and n are whole numbers, and they will be repeating if there is any other number when q has a prime factor other than 2 and 5. Say like 5 by 6. So 6 is 2 into 3. It has a prime factor other than 2 or 5. So 5 by 6 becomes repeating. And irrational numbers are those which are neither terminating nor repeating, like 5.98, 988, 9888, and this keeps on going in this way. So first there was 98, then 988, then 9888. So the number is not repeating. As the number is not repeating, so it doesn't come under repeating, and as this is continuing, this is not terminating as well. So such type of numbers are irrational numbers, and terminating or repeating numbers, these two sets comprises of the rational numbers. Q denotes the rational numbers and Q complement denotes the set of irrational numbers. So we'll directly jump to questions. Example 6. Show that 3.142678 is a rational number in other words, express 3.142678 in the form p by q, where p and q are integers and q should not be 0. The definition of rational numbers. So in solution 3.142678, we can write this upon removal of decimal, it becomes 3142678 by 1 0 0 0 0 0 0. So the numerator is an integer, the denominator is an integer, and the denominator is not equals to 0. Hence 3.142678 is a rational number. Next example. So terminating examples like this, terminating numbers, are very easy to show that they are rational numbers. Let's see how can we express repeating numbers in the form of p by q. Show that 0.3333 dot dot dot, that is basically 0.3, and we denote with a bar over here for recurring, can be expressed as 0.3333 P by Q, where P and Q are integers and the denominator, that is Q, should not be equals to 0. So solution. This type of questions have a special technique of solving them. So let's take x to be 0.3 recurring. So this implies x is 0.333. Let's say we repeat them 3 times. We can repeat them as many number of times as we want, but at least keep it 2 to 3 times minimum. So, and also one more thing, that you need to mention this dots. This dots denotes that it is repeating. If you do not mention this dots, then this number becomes terminating, which is not the case. Hence, these dots are very important. Now, next thing is how many digits are repeating. In this case, only one digit is repeating itself. So, if one digit is repeating, we'll multiply with 10. If 2 digits were repeating, we would have multiplied with 100, and if 3 digits were repeating, we would have multiplied by 1000. So here only one digit is repeating, so we are multiplying by 10. So let's take this as 1, let's take this as 2. 2 minus 1, we are subtracting them. So 10x is 3.33, so on, and x is 0.333, and so on. So on subtracting them, what happens is, after 3, this all digits are 3 basically. So 3's, 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 they all cancel out, and after decimal we only have 0, and 3 minus 0 is 3. Therefore 10x minus x is 9x is equals to 3. So x will be equals to 3 by 9, which is equals to 1 by 3. So we have denoted x in the form of P by Q, where P and Q are integers and Q is not equals to 0. So this is how we are going to show it. Next example, let's deal with some more questions relating the same. Show that 1.272727 ... that is basically 1.27 and a recurring on top of it can be expressed in the form P by Q, where P and Q are integers and Q, the denominator, should not be equals to 0. So, solution. We have x as 0.27 recurring. Sorry, 1.27 recurring. So 27 is repeating. This means x will be equals to 1.272727 ... We'll at least repeat them 3 times. So here how many digits are repeating? Since 2 digits are repeating itself, we'll multiply with 100. If 3 digits were repeating, we would have multiplied with 1000. So 100x is equals to 127 point. This decimal shifts 2 places. 27, 27, ... So let's take this as 1, this is 2. Equation 2 minus equation 1, we get 100x. 100x is 127.2727 and so on, and x is 1.272727 and so on. So we are subtracting them. So 100x minus x is 99x, and 1. See, after decimal we have 272727, 272727 and so on. So after decimal all of this cancel off. All of this will cancel off after this. So we are left with only 0. And 127 minus 1 is basically 126. So from here, x becomes 126 by 99. Which on solving, we get 9 11s are 99, 9 1s are 9, 36, 9 4s are 36. So x is 14 by 11. So this is our rational number. One more example relating the same. Show that 0.23535 which is equals to 0.235, and the repeating is only above 35, not 2. 35 is only repeating, can be expressed in the form P by Q where P and Q are integers and the denominator Q should not be equals to 0. Solution. First we'll let x to be 0.235 recurring. So this implies x is 0.235 35 35 ... So from here, as 2 digits are repeating itself, after decimal we have 3 digits here as we can see, but only 2 digits are repeating itself. So we'll multiply them by 100. If 3 digits would have been repeating, we would have multiplied by 1000. So 100x is equals to 0.235 35 35 into 100. So on multiplying by 100, it will shift 2 decimal places. So it becomes 23.535 35 and so on. So let's take this as equation 2. This is equation 1. So equation, we get 100x equals to 23.5353 minus x as 0.235 35 35 ... This is also subtraction. So 100x minus x is 99x, and on subtracting this, after this point 35 35 35 all of them cancel out, and 5 minus 2 we are getting over here as 3. 23 minus 0 is 23. So what we get x as is 23.3 by 99. That is equals to 233 by 990. Why are we taking off the decimal? Because the numerator should be an integer. So we are getting the value as 233 by 990. So the numerator and denominators are integers and the denominator is not equals to 0. Hence, this is a rational number. And the final example for today, find an irrational number between 1 by 7 and 2 by 7. In order to solve this, first off, what we'll do is we'll divide 1 by 7. So we'll take a decimal 0, 7 ones are 7, 3 in hand, 7 4s are 28, 2 in hand, 0, 7 2s are 14, 6 in hand, 7 8s are 56, 4 in hand, 0, 7 5s are 35, 5 in hand, 0, 7 sevens are, we have 49, we have a 1 in hand. So the digit is repeating itself. Again there will be 10. So once the digit repeat itself, what happens is 1 by 7 will be equals to 0.142857 and repeating in whole of this one. For 2 by 7, you do not need to find 2 by 7 separately. What you need to do is you take this number and multiply it by 2. 142,857 into 2. 7 to 14, 5 to 10 plus 1, 11, 8 to 16 plus 1, 17, 2 to the 4 plus 1, 5, 4 to the 8 and 2 ones are 2. So this is a simple trick of finding this one. So 0. We had this one, so it becomes 0.287. So 2 by 7 will be equals to 0.285714 and a recurring sign at top of this. This is our rough work. So 1 by 7 is 0.14287 and 2 by 7 is this one. So an irrational number between 0.14287 recurring and 0.285,714 recurring is, see, this is 0.14 and this is 0.28 something. So any number, let's say we take in between. So we are taking 0.18 say. So after this you can make your own pattern. So 0.18, 188, 1888 and so on. So this becomes an irrational numbers between these two numbers. So this is our solution. With this we come to the end of today's lecture.